Good day, Miss Daja. I'm Joseph Nathaniel Alhambra from STEM 1904 and I'm from Group 3. So, our topic is all about stratified random sampling. So, let's discuss our topic. Stratified random sampling. A stratified sample is a probability sampling technique in which the researcher divides the entire target population into different subgroups or strata, and then randomly selects the final subjects proportionally from the different strata. This type of sampling is used when the researcher wants to highlight specific subgroups within the population. So when we say it is stratified, it means that we're going to stratify a population into certain groups. And from the word itself is stratify, it means that we're going to form or we're going to arrange certain things based on their characteristic or traits. And the word subgroups or strata, they are basically the same. And it means that when we said subgroups or strata, you're going to form a group based on their characteristic and similarities. So basically, subgroups or strata have the are the group of people that have the same characteristic and they have something in common. So in stratified sampling, there are three critical elements that form this sample. The first thing is that we have the population, second is strata, and our sample. So our population is where all the members contained in a specific group. While the strata, just like what I've said earlier, oh my god. Strata, just like what I said earlier, it is the group of people having the same characteristic or they have something in common. While the sample is the representative from our strata and it is obtained through SRS or what we call simple random sampling. It is important to note that the strata used in stratified sampling must not overlap. Having overlapping subgroups will give some individual a higher chance of being selected as subjects in the sample. If this happened, it would not be a probability sample. Some of the most common strata used in stratified random sampling are age, gender, religion, educational attainment, socioeconomic status, and nationality, and of course, there are more. So, for us to better understand this topic, let me give you an example. So, for example, let's say this is all about the university student. And my example is that there are population of 1,000 university students. So, the first thing to do is to identify what is your population. And my population for this example is 1,000 university students. So now, let's find out what our subgroup or strata is. So, in my example, I will give this first strata as our freshman from 1,000 university students. So this is our freshman, the first strata. The second strata would be our sophomores. Our third strata is our junior. And last but not the least, our fourth strata, which is our senior. So after we identify our different strata, we're now going to get a sample from our strata using SRS or the simple random sampling. So to perform stratified random sampling with 200 pieces of the data, so in my 1,000 university student, I got 450 from freshmen, 250 from sophomores, 200 from junior, and 100 from our senior. So after we identify the strata, we're now going to get our sample from our strata using SRS or what we call simple random sampling. So in selecting a sample from our strata, it is critical to select an appropriate number of sample in the strata. So for the sophomores, for the freshmen, I'm going to get 45% because there are 450 person in there. So for the sophomores, I'm going to get 25% of 250 people. For our junior, I'm going to get 20% in 200 person. And for our senior, I'm going to get 10%. So in 45% of 450, we have 90 freshmen in our stratified sample. And for our sophomores, 25% of 250 is 50. So we have 50 sophomores in the stratified sample. And for our junior, I'm going to get 20% of 200, so we got 40 from our junior. And last but not the least, 10% from our 100 students in senior, and I got 20. So you now have the final stratified sample. So this is now the answer. So now you can now analyze your sample, and this is how you do it. So using stratified random samples ensures that there will be selection from each subgroup, just like what I've said earlier. Otherwise, if there is a subgroup that is not selected, that subgroup characteristic would not be included in the final analysis sample. So it is critical that we use stratified random samples because it is precise and it ensures us that there will be a characteristic from different strata, and so that our final stratified sample is precise and reliable. So when to use a stratified sampling? First, just like what I've said earlier, the researcher wants to highlight a specific subgroup within the population. It is also used when we want to observe relationship between two or more subgroups or strata. So, researchers also use stratified random sampling when they want to observe relationship between two or more subgroups. With this type of sampling, the researcher is guaranteed subjects from each subgroup are included in the final sample. Whereas simple random sampling does not ensure that subgroups are represented equally or proportionally within the sample. So it basically means that stratified sampling it ensures us that we're going to get exact and precise final stratified result, so that we can use it in other data, and we can ensure that it is reliable, unlike the simple random sampling. So there are two types of stratified sampling. The first one is the proportionate stratified random sample, and the second one is the disproportionate stratified random sample. So the proportionate stratified random sample. In proportionate stratified random sampling, the size of each strata is proportionate to the population size of the strata. Look at across the entire population. This means that each stratum has the same sampling fraction. For example, let's say you have 4 strata with population sizes of 200, 400, 600, and 800. If you choose a sampling fraction of 1/2, this means you must randomly sample 100, 200, 300, 400 subjects from each stratum respectively. The same sampling fraction is used for each stratum regardless of the differences in population size of the strata. So, for example, let's use my example a while ago. So, let's say the first strata is the freshmen. This is the sophomores. This is the junior. And the seniors. Let's say that we have 200 freshmen, 400 sophomores, 600 juniors, and 800 seniors. So let's say I pick the sampling fraction of 1/2. So in proportionate random sample, I'm going to decide what is the sampling fraction of each strata. So I decided to do the 1/2, and I'm going to randomly sample this 4 strata by 1/2. So I'm going to get 100 sample, 200 sample, 300 sample, and 400 sample. So that's how you do the proportionate stratified random sampling. So the second stratified random sample is the disproportionate. In disproportionate stratified random sampling, the different strata do not have the same sampling fraction as each other. For instance, if your 4 strata contain 200, 400, 600, and 800 people, you may choose to have different sampling fraction for each stratum. Unlike the proportionate random sampling, you're going to decide the same sampling fraction for each strata. Perhaps the first strata with 200 people has a sampling fraction of 1/2, resulting in 100 people selected for the sample, while the last strata with 800 people has a sampling fraction of 1/4, resulting in 200 people selected for the sample. So just like in my example, just like my first example, this this is a type of disproportionate random sampling because I didn't decide for the same sampling fraction, and I decided to use different sampling fraction. For this first strata, I decided to get 45%. For this second, 25%, third, 20%, and fourth is 10%. So basically, this proportionate stratified sample does not have the same sampling fraction, and you're going to decide for the appropriate numbers of sample of each strata to finalize your analysis sample. So that's how you do the disproportionate random sample, just like what I did a while ago in this slide. So what are the advantages of stratified sampling? So it ensures that estimates can be made equal accuracy in terms of characteristic in different parts of our subgroup or strata. And it also improved population representatives in a study. So basically, stratified sampling, it ensures that whatever you will get in the analysis in samples will be a reliable for your information that you can use in other research. And the disadvantages of stratified sampling is that the main disadvantage of stratified random sampling is that it can be difficult to identify appropriate strata for a research. And the second is that it is more complex to organize and analyze the results compared to simple random sampling, which is much easier to do. But in simple random sampling, you're not going to get the characteristic of each strata, unlike the stratified sampling. There are strata, and you're going to and it will ensure that you're going to get each characteristic in the final analysis sample. So for me, I'm going to use stratified sampling because it will ensure that I will get a reliable final analysis sample. That's all. Thank you.